This is 2716. This is kind of an annoying problem that says they're going to give you a certain amount of a material of mass M and density rho M, and I want you to make a wire with a resistance R and has a resistivity rho. So what geometry do you need to use to make it a resistivity or resistance R? And then when you do that, what length and diameter do you need as a function of all the other parameters? So it's annoying because it's highly symbolic. It's annoying because it uses rho for the mass density and rho m for the resistivity. And it's annoying because it asks for the diameter instead of the radius. That's just off the top of my head. Okay, so let's see. So, okay, what are we going to do? Okay, we know that it's also annoying because it doesn't say that the wire has a circular cross-section. But it asks for a diameter, so we're going to assume that we have a circular cross-section of this wire. It has some length L. It has some area A, cross-sectional area A. It has a mass M, and it has a density rho M. So you can get the volume by using the mass and the density. And it has a resistivity rho. It has all those things, and therefore presumably it also has a radius. The area gives you a radius as well. So it asks us for both the length and the diameter. So there's sort of two unknowns. We need two equations. So one that we're clearly going to use is that the resistance that we're going for, we want this wire to have some resistance, always equals rho times the length over the area. But we're going to go ahead and write the area in terms of the radius. Okay? Pi r squared. We could go straight to the diameter, but then it would be pi d over 2 squared, and then you'd have a 4 running around, and it's kind of a mess. So I think it's best just to go ahead and write it as rho L over pi r squared. We can find the length and the radius, and at the very last step we can just double the radius to get the diameter. That sort of minimizes some of the algebra. So I'm going to call this equation A. So you could say we're done. We just solved this for L, we solved this for R, and we're done. But that's not really solving it. We're trying to get L and R independently. So one equation isn't enough. We have two unknowns. We need two equations. So the other equation is simply to use the relationship between the mass and the density. And we have the volume. So you can just say also the mass equals the density, rho m, times the volume, and the volume is what? It's the pi r squared, that area, times the L. And that's equation B. This problem is also annoying because you often end up in the solution writing rho times m, and then you also write rho m. And it's hard to keep them separate. So anyway, we have now two equations, A and B, two unknowns, L and R. So we just start plugging one into the other. So the path I took, and there's many paths you could take to get there, is I solved B for r squared. Equation B for r squared. So let's see, equation B for r squared is just m over all these other things. Right? Is r squared is the mass over rho m pi L. And then you take that and you plug it into A. Right? So solve B for r squared, plug into A. And let's see, it's down there. So then you would say R equals rho L over pi, and then r squared. It would have been easier to leave, oh, never mind, okay. Over pi, now r squared. So now this r squared is going to be m, and instead of writing this as another denominator, I'm going to write this denominator up here. Okay. So m over rho m pi L. So you can look at this and you can see the pi's go away, like that. And what we want to do is solve it for L. Well, now L has come in squared. So now we have that R equals rho rho m L squared over m. And we just flip everything around, solve it for L squared, take the square root, and we get that L equals the square root of what? Of R, big R, m over rho times rho subscript m. That's right. And if you work out the units, it all works out. You get all these units combined and gives you mass, or it gives you length, gives you meters, which is one way to check it. So when they ask what is the length, L, this is the answer in terms of the things given: the resistance of the wire, the mass of the wire, the mass density of the material, and the resistivity of the material. So now, to get the radius, and therefore the diameter, again, there's a lot of ways you could do it. You could go plugging this into either one of these, if you want. Or you can just start all over, and you can solve B for L, and then plug it into A. I think that's what I did, actually, yeah. Yeah, so now let's solve B for L. So there's a lot of ways. I'm not sure of the many ways you could do it, which one would be the least algebra. So I'll just do the one that I made notes for. Again, solve equation B. Now this time solve it for L. Well, L is m over rho m pi r squared. L is m over rho subscript m pi r squared. Okay. And then m over rho, and then plug into A. Alright, so then we come back here and say A looks like that. So I'm going to go ahead and solve it for L. Or no, we wouldn't want to solve it for pi r squared. Let's just go ahead and plug it in. R equals what? Rho times L, and L is now what? L is m. In the denominator we have to put rho m pi r squared. So that whole part is just rho times L, and L put some things in the denominator, and then we still have another pi r squared in the denominator. Alright, so that's looks horrible, but really there now all we have to do is solve for R. Right? The question was, we're looking for L and the diameter, really we're just solving for the radius. So to solve this for R, I don't know, we can't simplify it too much more. We can say the big R resistance is rho times m over rho m pi squared r to the fourth. Then bring that r to the fourth over here, bring the little r under there, and say R is the fourth root. So we have r to the fourth. It's the fourth root of rho, the resistivity, m the mass, over rho m, the mass density, pi squared, big R. And there the units will work out, that's correct. But then of course they ask for the diameter, so now's your chance to double it. And while we're doubling it, just for fun, why don't we go ahead and pull this pi squared out of the fourth root. We pull a pi squared out of the fourth root, it's the square root of pi. So we could write it like this: 2 over the square root of pi times the fourth root of rho m over rho m r. And that is d, the diameter, in terms of what you've been given: the mass density, the resistivity of the mass, and the resistance you're trying to make. So again, 100 ways you could do that, 2 equations, 2 unknowns, but they should always get to the same answer.